In this video, we're going to pick up where we left off in using Microsoft Excel to calculate 95% confidence intervals. And just to review, we're going to calculate two different confidence intervals, one which uses the z-statistic and the other uses the t-statistic, the former when you have a very large sample size, and the second is when you have a relatively smaller sample size like we do here in this particular example. So we had generated a number of statistics that sets us up for making this calculation. Now to do this, we're going to start with the first equation, and we need to compute the product that appears after the plus minus symbol, and we'll do that for both equations. And that's where we take our z-statistic that corresponds to the 95% level, and we multiply it by the standard error of the mean. And I'm going to put that value right in this cell here in C2. So I'm going to highlight C2. And I'm going to hit the equal sign. Now I go look for my z-statistic because that's what I had calculated in the previous video, and I have that labeled right here. I'm going to shift 8, and I'm going to multiply that by the standard error of the mean, which I have right here in B16, and I hit enter, and we have a quantity that we apply in the first equation of 2.89 repeated. Now we're going to jump to the second equation, and we're going to perform the same calculation. We're going to compute the product on the right hand side of our plus minus symbol. So I'm going to put that right in this cell, and I'm going to start with the equal sign. I'm going to go get my t statistic, and I'm going to shift 8, and I'm going to multiply that by the same standard error I used in the previous cell. And I hit enter, and we see two different values. Even though the standard error is the same, these values are different because in one I'm using the z-score 1.96, and because the t-distribution is more platykurtic and the data are further distributed, we expect to see a larger t-value which spreads out that 95% interval. The final step here is to compute both the lower limit and the upper limit for each of the two equations, and I'm going to start here with the first equation. And what I need to do now is I need to take the average score of our sample, which we had calculated previously, and the first thing I'm going to do is I'm going to subtract the product of these two factors which I had just calculated over here. So I'm going to put that in this cell, and I'm going to hit the equal sign. I'm going to go find my average score, which I have in this cell, and I'm going to dash or subtract the product of z times the standard error, and I hit enter. And that gives me the lower limit for my 95% confidence interval of a large sample. Now again, this is based on these data, but we're just going to apply this equation right here for demonstration purposes. Now for the upper limit, we follow the same pattern. So I'm going to hit the equal sign. I'm going to take my average, and this time I'm going to add it to the product of z times the standard error. So now we have a 95% confidence interval that ranges between 25.99 or 26 to 31.8, and what we're stating here with this confidence interval, that with 95% confidence we can state that the population average likely resides within this range. But now I want to repeat this for the second equation using my t-statistic, and the second equation is by many accounts a more appropriate one to use because we do have a relatively small sample size. So I'm going to follow the same pattern. I'm going to hit the equal sign. I'm going to get my average, and I'm going to dash. I'm going to subtract that now from the value of t times the standard error. I hit enter, and I'm going to repeat that for the upper limit, but I'm going to use the plus instead of the minus. Hit the equal sign, find my average, and this time I add the product of t and the standard error, and we have this value here. So comparably, if we calculate the 95% confidence interval using the t-distribution, and there's justification for doing that because of the small sample size, here we see an interval that ranges from 25.5 to 32.3 compared to the 26 to 31.8 confidence interval when using the z-statistic. So we have a wider confidence interval by virtue of the fact that the t-distributions are more platykurtic than the z or normal distribution, which would widen the confidence intervals as expected as we see in these data. So this ends our second video on using Microsoft Excel to calculate the confidence interval.